I wanted to introduce a bit the density-based clustering method. Okay, so for example, in density-based clustering, we can detect forms like this in our data set. And so this is using dbScan. We put a threshold on the density. But one of the limitations of dbScan is when you have, for example, two clouds of words, but in one cloud, there are subclouds. And so either you put a threshold that will detect the two large clouds, either the two small, but you can't understand both. So this is where optics comes to play. This is the reachability plot from optics. The valleys show the clusters. And so here we can say this was our left cluster, and here are our subclusters that we previously couldn't find. So this is optics. And during my PhD, I developed optics KXI to be able to extract the clusters from the optics reachability plot. I believe HDBScan may be doing similar things. In my optics KXI package, I provide some functions to be able to compare various parameters. We don't know the number of clusters we're looking for, so that's one of the things we compare. This is the results on the first example on the shapes. So here is the example of the metrics that optics KXI uses to be able to say, okay, this is the best model. The clustering is best like this. So on the left, we have the different types of models. We had Manhattan distance. Xi3 will determine the number of clusters. Points 20 is the density parameter. So this enables us to rank our models. And after that, we can show the optics reachability plots with our different clusterings and see how, and to be able to fine tune if we need, if we don't want to, if, for example, this one looks better or not. So. And last, we can come back to the original data, map the clusters, look at the discriminating features.